Scott and Frank, we're doing a double today. This will be exciting because you guys are building something together. It was tough to separate you two on this one. Tell us what you're building. What are you guys building?
What we're building is a simplified and well, I mean, Docker makes a lot of things simple, but a nice, easy way to get the Elastic Stack set up the way that Scott and I see it. There's a lot of people out there that Dockerize Elastic or put something in Docker Compose, but we kind of did it to the way we see it in like our DoD spaces with certificates and getting it out, with the air-gapped environments, with our package repository and artifact repository as well.
Awesome. So that's what we're going to talk about. We're going to walk through the actual install today and throw the covers off, help explain what you did, and then where you see this could be of value to people. Tell me a little about yourselves before we get into that. Frank, you were just talking, so let you continue, Frank.
Yeah, awesome. Thanks. I was a software developer prior to working at Elastic. Did some Elastic consulting for a little bit. Spent some time in the U.S. Army Reserve for a hot minute. And yeah, that's pretty much me in a nutshell. I've been at Elastic for 3 years, kind of live in the Virginia area. And yeah.
Awesome. Is there Scott?
So I'm a recent addition to Elastic within the last year or so. Prior to that, I was in the Air Force. I retired out of there after a number of years and doing cyber defense. And prior to that, being a programmer. I'm enjoying being here, figuring out how to make this the use cases that I saw while we were in the Air Force.
Awesome. All right. Yeah. So, I mean, let's just jump right into this. You made a Docker image, put it on GitHub, how to get Elastic on an air gap environment, non-air gap. That's a very quick element, but why did you make this? Let's start with that. Why did you make this?
Yeah, so the one thing that we saw is that everybody's kind of got their own take on how to deploy Elastic. I mean, it's a very broad, and there's a lot of different ways you can do it. And we chose the way that we think you could get started to educate yourself or to deploy it for a POC or to deploy it in an air-gapped environment the simplest way. So we went with Docker Compose files. We went through trying to do this via Kubernetes, trying to do this with just standing up container images with shell scripts or something. And then we've also done like RPMs. And we felt that Docker Compose gives the best and simplest experience for somebody that might not have a lot of expertise in these other deployment methodologies. And I think, Scott, you have a terminal window up with the stuff. Okay.
Cool. Yeah. And to go off what you were saying, it was basically an easy use. A lot of people that we've encountered want to know how to engage and use Elastic. They're less interested in how to deploy it. So we're trying to lower that barrier to entry so somebody can have a usable system that they can tinker around with and get data in and start building dashboards and seeing the benefits of Elastic.
Yeah, I mean, let's be honest, as we are very robust. Elastic is a very robust product. Air gap, we have so many customers, so many people using us in the air gapped world. To get the whole solution installed on air gap, it's a single product. Like you're not putting 15 products together. There are a few minor things that make it a little more complex to put it on air gap. And so what you have done is you've made those available just instantly, plug and play, throw it back in there, throw it in, I would imagine, is what you're talking about.
Exactly. And one thing that we've also done architecturally is with Docker Compose, you can kind of create smaller compose files within that. A lot of projects out there, they like to put it in one file, so you have one large YAML file. So what we did to kind of help that education piece is split it up into different compose files. So if you want to take a look at how to do this in your environment separately, you have a really discrete example of how to do this with the ERP, how to do this with the EAR, how to do this with an ML node, or how to do this with security in some case, right? So we really took this from an education first standpoint so that you can look at it and go, okay, this is the part I need. Here's how I put it into my stack too. So there's also that component of it as well.
That's a good point. What is the ERP and those other elements you just shared? Because I think that's what we're going to be walking into. Give a quick description of what those are. I mean, there's Kibana, there's the Elk, Elastic, Kibana, if you need it, Logstash. That's the classic cluster right there. You're bringing up a couple other things. What are those things?
Yeah, so the ERP and the EAR are the Elastic Package Repository and the Elastic Artifact Repository. So when you work in an air-gapped environment, you need some way to interact with the Elastic out-of-the-box solutions. And these are those particular repositories. So the ERP, which is all the different policies, dashboards, integrations, things that work with agents, that all is packaged into a Docker container. And then you can stand that up in your site or wherever you need to, so it can operate as if it were working online. And the EAR is if you have to upgrade like an Elastic agent. How do you go through with that process with the one click on the web? That's super easy, but in an air-gapped environment, you need to have those packages stored somewhere. And we take that process of kind of building the HTTP server, putting all the packages in there. We set it all up for you. So all you have to use is the Docker Compose file. It pulls down everything, and then you can bring that over in interface and then stand it up in there.
Okay. Any other components with the agent, for instance? Any other elements like that that are part of this architecture?
So base architecture, go ahead.
No, go on.
So with our base configuration, what we consider the standard node. So if you just ran Docker Compose up, you would get a 3-node of Elasticsearch, you would get a Kibana node, and then you have the Fleet server that gets installed as well and configured. One of the other things our customers
with the ER,
especially in
EAR as well.
No.
Continue.
So the base cluster is just the 3 nodes with Kibana and Fleet. There's also TLS search that get generated as part of the startup and get pushed out. So the configuration within Docker shows how to do the self-signed search. So that's one of the other major things that our customers always ask about and are always looking for examples on how to do. So we have that in there. As far as the EAR and EPR, those are part of one of those separate YAML files. So we have an air-gapped YAML that you can, and the instructions show you how to do it. You basically combine the 2 Docker files using Docker Compose command, and it has the changes that need to be made to the Elastic Stack to set it up for air-gap. It tells Elasticsearch and Kibana how to reference the EAR and the EPR and makes those configuration changes for you, so you can see what changes are actually being modified or configurations are actually being modified.
And this will automatically set up like the configurations in Fleet 2. When it's all stood up with the Compose file, you're just ready to lock.
Of note, how long have you guys been working? And this is not your day job, right? So how long have you been working on this on the side? I bring this up.
Total or just the Docker piece?
Well, I bring this up because this is a new concept. You're building this, and you expect new iterations to come as well. So,
correct.
Yeah.
This isn't exactly a new thing for us. We found other examples. There's old elasticians who, like a year ago, there was an elastician who put out a project. What was it? I'm trying to look for his
Just the
name.
coolest.
Elk Ninja. Yeah, Elk Ninja put out a blog post over a year ago, and we took that as the basis and built off it. So we didn't come up with this totally on our own. We're just trying to make use cases and examples for customers and bring out a training value to it.
Well, should we get into it? Let's see. Let's see how to do it.
What configuration? So we have profiles that we put into Docker Compose. There's the base stack, air-gapped, obviously, and then we have a bunch of profiles for initial examples. Scrolling through the page, we can set up a machine learning node for a profile. We have stack monitoring, Logstash. We have a application performance monitoring example that can be pre-configured, and Elastic Agent.
Let's do air gap. Is it? I mean, I assume it's just an extra variable, an extra parameter, right?
Yes.
So let's do the air gap parameter and assume it's the same methodology for all the others.
Yeah. So the air gap and the profiles, we can do it either way. I'll do monitoring just so we're getting some interesting data in here as well. All right, let me share this window.
And while you're building that, what are some use cases? Let's walk through that first before we walk into it. Where do you see this being used?
So what I think there's a lot of different places where this can be used. One of my favorites is the education piece. I've had a lot of different, cybersecurity analysts or somebody that's working on their side project for whatever tech stack they're trying to do. And they just want to kind of mess with Elastic. They want to interact with it and test it out. I think the education component is a good use case. Customers that really want to just see how it looks in their environment, test it out. This is also another great use case for them because they don't want to spend, weeks trying to learn how to deploy the stack. They just want to see if the product's actually going to work. And this is a great way to get that going. And, as we're seeing it's building right now as we're talking, this is straightforward, simple. We're going to have an air gap set up here. And the only difference, if you actually did want to bring this into an air gapped environment, is we pull down the containers. We load that up onto like a CD or some other way to transfer that over to the other environment. And then we just load it up there and we're good to go. And it's just a small additional step to kind of build everything that we need to build.
You can run this. It will build the containers if they don't exist. So if you ran this on a laptop or some kind of internet connected service or computer that can pull down those containers, it will build the EAR and DPR containers for you. And then you can just take those images into an air-gapped environment.
So so then that makes sense. So that's the difference between air gap and not. Right now, you're grabbing the data from these containers from the internet, but as long as you had already grabbed them, put them on a CD, pointed this command to, like, if you had a Docker repository, basically, you just put it in the Docker repository and be able to grab them that way.
Yeah, you would load correct.
And I mean, we're waiting for the EPR, but this is it. That's the command. Correct?
Yep. It's pretty robust. Once the EPR comes up, so right now, Kibana is just created. The only one that's up is the Elasticsearch node. The EPR will not, or Kibana will not come up until the EPR is loaded because Kibana has to load a bunch of plugins for Fleet, and it needs to know where to talk to get to it. So there's a delay. So now Kibana is coming up. Once Kibana is up, Fleet will be able to start coming up. So we've got it in order of operations to how these things come online.
If we have time, could you walk through each of these different volumes and containers? Like high level, what are we looking at? Why are they separated like this? What are we seeing?
Basically, just to be able to maintain data. In the Docker Compose, the ES cluster for certs, that volume is where all the self-signed certs are being generated and shared between all the clusters. And then this can persist data. If you're storing stuff in your demo, you don't lose it. It's just persisting the volume between Fleet and everything else, storing its logs and settings and things like that. So now it is up. So I'm going to switch windows here.
Yeah. Show us what you got.
So this just comes up on localhost 5601. I get to figure out how to switch this. This is one of those post-process things.
And after we get through this step, we will walk through the code because for one of the use cases, as we were talking, one of the use cases is this is a great, get something up and running, get a pilot running, POC running. Don't have to worry about that timing. But when someone starts going into an enterprise prod type architecture, they'll want to make tweaks to this. And so I want to walk through the code to help us understand what you built so they can make minor tweaks, that they don't have to recreate the wheel. They can simply work with what you built.
Okay. So in the env file that the Docker Compose is using, you set the default username and password. So it's just Elastic and change me. Super simple.
On localhost, I noticed.
Yep.
Which makes it even easier. Makes sense.
You're going to specify in the env file the external IP It enables you to actually connect external
Oh, okay.
Fleet agents to your host. So what we did in setting up air-gap, the easiest way to see where the changes are being made to it is in Fleet itself. So in Fleet, you can see we have the Fleet server set up. Inside this policy, we now have APM, our application performance monitoring, Docker, since we're running in Docker, so it's going to pull those logs. You have the Fleet server, agent server, and the standard system one. But in our settings is where you'll start to see. So this is the local IP I'm setting in the env file. So it's telling Fleet where to go find itself. And then you have your EAR that's set up down here, and that becomes the default. It's set as the default. So when you're installing agents or upgrading agents, it knows where to go to get those updates. The EPR, I don't know if I can see it in here, is set up, and in the log files, you'll see it reaching out to the EPR server to pull down all of these integrations. You still have access to all of the integrations with Elastic. You can install them, run them. If you want Elastic to plan, you can put that in. Everything is fully enabled. The env file I'm using has the trial license automatically enabled. It's just uncommenting out one field and commenting out another, changing one value. You have full use of everything in here. One of the things that we did within, and this is not part of the monitoring profile we set up, this is just default, the way it comes configured. Search and Kibana are pre-configured with APM. So you can immediately see what's going on in your cluster and how the cluster is performing. You can see what kind of data is passing through it. It's not something that I've seen normally pushed out in installs, but we wanted to do it just so that you can see what's going on behind the scenes with Elastic.
Yeah.
And this is really good for the education component too, because you can say, okay, when I actually interact with the dashboard in Kibana, what are all the subsequent calls that are happening, right? So you can get that deeper understanding of not just how you interact with the product, but how the product interacts with itself.
Yeah, you can see the actual transactions, ones you actually did in that demo we just showed.
Yep.
And the time it's spent in each of those transactions. So yeah.
And then since we did the monitoring, what the monitoring profile is doing is setting up a metric beat in a container and monitoring the Elastic cluster that you just set up. So if you go to stack monitoring, it will be pre-configured to show you everything that's going on. Your nodes, latency, what's going on, the percentage of utilization, disk space free, how the nodes are configured, the standard data you would expect to be able to see.
Yeah, love it. Yeah, so it's definitely healthy. It's running 3-node cluster. Your env file helps you describe if you want to separate things on different IP addresses. Yeah, it's working. It's definitely working. Before we walk off of this demo, any other things you want to share before we start looking at the code?
Frank?
Not really. The self-monitoring is kind of a nice to have, definitely. You really have everything at your fingertips here, which is nice. And we saw it took just a couple minutes to get up and running. And this is fully, your environment. So I don't think I have anything else to add here.
Okay, well,
It's a Elastic cluster.
Since we do have this running on Docker and we did install the Docker integration, you immediately will have a Docker dashboard to show you also why which stack is running.
Makes sense. See actual images right there.
Yep. The data is being passed in, so you are ingesting data. There are...
You're building your own pilot with your own data.
Yeah. We just put it up and we already have 800 up. So, or 800 logs.
Yeah, that's awesome. Okay.
You said you wanted to look at the code.
Yes. So this is on GitHub.
Yep.
What is the repository name?
We have it under Elastic Stack Docker.
We can put this in the description, right?
Sure. Yeah.
I totally get that line.
Awesome.
Let me open this up. So this is not on the official Elastic repo, because this is something we've been doing on the side. So we just put it in our personal repos. So here is the page.
First of all, options. Let's that README. So there's respectable instructions there.
Yeah, and we're gonna go through and update these instructions a little bit more to add, what particular configurations in the env file stand for. As we build additional profiles, we're gonna create what those flags are and then specify what those profiles exactly are, what we architecturally designed for that. Because I think kind of the future conversation of that is what those profiles look like. So we can talk about that a little bit more later.
Okay. Yeah. Yeah. What your future goals are. I like that.
Mm-hmm. Frank has quite a few good goals that I'm looking forward to working with them on. So this just basically runs through the different steps for setup, changing the env file, startup commands to deploy, and then it runs through what the air gap is and gives example commands for how to bring that up with different monitoring or profiles, or just bringing up the base air gap stack here.
Awesome.
And then it goes into a little more detail about what the individual profiles do and what it brings up. So the APM one will actually start a web app and bring that online that you can go through and access and generate errors that you'll see in the APM dashboards within Elastic.
Okay. Oh, so you have a sample web app. Okay, that's cool.
Yeah. We stole that, I think, from Elk Ninja, I think is where we got that. We pieced together a lot of things to make this work. We find that working examples are great to incorporate into different pieces of this. So I'll go into the code and the basic compose file. All right. So this is in the services, this is the setup service that is generating all the self-signed certs and provides an example of how to do this on your own if you want to do it. Or the best use case within DoD I would see is where it's storing them and then how these certs are being distributed to the different components so that you can implement TLS with whatever certificates you want to use.
And it would be right. Yeah, you'd be able to choose your certs via this. Yeah, you make that configuration here.
So like this is node 1 of Elasticsearch, and you can see where the certs are being brought in.
Yeah.
Up here, so we're saving them there, and then how they're being called is all down here, and you can see how to enable it. You can see examples of how to enable a multi-node cluster, so you can see the discovery seeds, what the master nodes are going to be, the different configuration parameters we're using, and then you can refer to our documentation for any specific details. Well, the Elastic documentation of what these parameters are doing. And we're passing most of these in through environment variables. There are a few configuration files we're using that these will call into play. So like the Elasticsearch configuration here is referencing the Elasticsearch. I'm going to switch to it in the config file, and this is setting up telemetry. So this is what is enabling you to do your APM integration off the bat. It's turning on the key features that it needs that it wouldn't basically have unless you went would set this up.
So you have 3 Elasticsearch nodes. Are they all using the same YAML then?
Yep.
Okay. I noticed.
You don't have to.
I noticed that the Docker compose YAML, when you looked at the Elasticsearch, yeah, the image. So you're grabbing the Elastic image from a website, which at this moment is a website, but you could easily make that internal to your network right there.
You don't even have to. This is our official repo. When you pull this down, it's still going to be tagged this way locally. So if you import that image in, you can just use the tags to pull it. If you wanted to change the image to something specific, you can, and it will work.
This would be a decent time to plug our relationship with Iron Bank as well. Anyway, yeah, continue.
So these are the 3 nodes. They're all identical, other than the host seed. They all point to another host seed, so they know how to join the cluster. And then we have our Kibana integration, again, using certs. So it's pulling in that certs volume. And then your configurations for how to use certs and the different encryption mechanisms that are from the env file. And then finally, we have the fleet server. This one, we did a little differently. So this fleet server is in an air-gapped environment. I will go into the air-gapped YAML. We had to make some minor modifications to it, and we did that through the configuration, and it's all done behind the scenes. Fleet, how to instrument this certificates within Fleet so everything works. And then I'm going to jump to the air gap. So the second part of my command that I ran was tacf air gap to merge these. This is the configurations that are required for an air gap environment. The EPR is pulled from the Elastic Package Registry. And then the EAR we're actually building. It's using scripts that you can find in the Elastic documentation to piece together all the artifacts that are needed for agent.
And to add in a little bit here, this is where kind of we were talking about the education piece and really breaking down to the straight components of the deployment process a little bit more. So because we split them up into YAML, like separate YAML files, it's a lot easier to see, okay, if I want to use this, what do I do? Okay, you come to this file, take a look at all the configurations. Here's how we do it in this Docker environment. So it helps kind of logically in your head break out what you're doing, why you're doing it, and all those associated things. We could have easily threw this all into one file, but I think it was a key architectural decision to make that more coherent for the end user and listener.
And on that topic, what are the prereqs? If someone wants to install this, it's just Docker, or are there other things as well?
Should just be Docker. Let me go look. It's in the README. Jump to the README. I write this out. Yeah, you want Docker Compose version 2.20.3 or greater. And that's because we're using the profile features. So you want to be able to have that enabled. But yeah, that's the only requirement.
Okay.
Going back to the air gap. So Kibana, the changes, this is how you tell Kibana to use the EPR that you have locally. And it's using the internal Docker network because you're bringing it up within it, the URL for it. So it just knows where to find it and gets it. So like I said, for Fleet, we're changing stuff because we're doing an air gap setup on Fleet. And what we're changing is we are adding the download sources for the EAR. There was no easy way to do this through a simple environment variable. So we're using the Elastic API to update where the artifact repository is, or registry is.
Okay.
And then we have the examples. So this is where monitoring came from. Here's the examples for all the different profiles we have. The ML profile just takes the existing cluster and adds a node to it that's dedicated for ML. It has a little bit of sizing differences, so you can install Elser into it and do vector searching on this POC type environment. And then we have metric beat, which we have pulling the metric beat out, or excuse me. We pull down metric beat and install it to monitor the Elastic cluster. File beat is, we have file beat and log stash profiles. They're basically there to show you different routes to ingest data. And you can play with the configurations. Log stash, you can monitor or modify the log stash configuration YAML to try different ingestion pipelines and make things work. See if you want to bring in data types. If you got some kind of logs from something, I don't know, Cisco router or something, you don't want to do the integrations, you can bring the logs in that way. Put them in a directory and it just pulls everything in for you. So we're trying to make it as simple as possible to bring in data to play with.
Tell
And
me.
then for,
Oh, go ahead. I was going to say, sequence. I see a .sh file. I see a lot of YAMLs. You have the Docker Compose you run. How, and maybe this is more of a Docker question, how do you sequence those actions? Is that in the compose file? Or is
Yes. This one won't have it. So most of the compose files, you have the depends on, which is doing a sequence in Docker. So this is the ML node won't even try to come up until
I see.
BS1 is healthy. So we did health checks on all the components so that we can get their health state, and those, when they come back as healthy, we'll kick off other quirks to start up.
Okay, cool. I mean, this is very solid. It looks pretty simple, honestly. Well, I mean, no, let's not pretend it's simple, but it's well organized is the right term.
So that's all, Frank.
And the best part too is we put a lot of the configurables into an example as well. So we have an example env file that you can bring into when you clone the repository. This is going to simplify a lot of that. So if you're not familiar with Docker, looking through all these configurations might give you a little anxiety, but so we pulled that all out and we put it into very discrete. Okay, you want to add your host IP. Here you go. You don't want your password to start out as change me. Put something else in there, right? How do we simplify that for somebody that's not, very familiar with Docker, very familiar with these other technologies? Well, here we go. We got the examples, and as long as you read the README, should be okay.
So that the CMV file really is the only place, at least for people doing pilots and trainings, not planning on augmenting, changing this. This is the only thing they will really work on.
Yep.
Cool.
Run the one command that Scott showed after making edits here in the env file, renaming it, and you're off to the races.
And all options are in that env file. There is
The key ones, yes. Mm-hmm. If you're doing this in a production environment, you're probably going to want to make changes within the code for your own environment. But for somebody just trying to learn it or play with it and see what it can do, this is all you need to mess with. The ports you don't have to change unless you happen to be running this on something or on a host that's already utilizing those ports. So like 8080, that's the package registry port. You can change that if you need to, but most cases, if you're running it like on a laptop or a PC that isn't a server, you probably don't have those ports in use anyway.
When we talked, Andrew McElhaney, when he and I talked, we were talking a lot about training, and I think this is a very element. Consistency between environments was a huge topic. And I think this and that discussion really work together because this gives you that consistency. Everyone can have the same environment. You can throw it up pretty quickly, learn very fast, destroy it, no issues whatsoever. If you want to augment this code to be a little more different, to be more of what your prod is. Like if you built prod off of this, you can turn that into a training system as well that someone can spin up and spin down very quickly as well.
Mm-hmm.
Yeah, I think this goes back to there was our origin story in the DoD is really consistency. It was red teams, blue teams. The offense was always winning. A bunch of the defense team, the blue teams were like, you know what, we're gonna beat them. But to beat them, we need to be consistent. We need all of us to have the same system. I know that you're the expert on network and you're the expert on I'm trying to think of anything on Cercada, but we all are gonna have the same system so that we know what we're looking at, and that allows us to be better. And they actually did beat the red team, and that's really where Elastic started its origin within the DoD, is that story. So yes, like consistency for training, helping not just the smart people, but everyone get a leg up and get moving forward.
And this really helps build that consistency. I mean, Docker is a great technology for consistency, and you can have that across multiple different operating systems. I mean, that's just the story of Docker and how it operates. And leveraging a lot of that and using Elastic on top of those techs makes us very consistent.
All right, so
Future uses?
what was that?
Did you want to go into future uses?
Yeah, let's go for a few. Yeah, yes.
I'll let Frank go since he's like directing our way forward. Do you want me to pull up the issues thing, or do you just want to talk to it?
No, we're okay. I'll talk to it. So like a lot of what we want to do with this project is speak a little bit more to explaining the different architectures in Elastic. I love talking about Elastic as an iceberg. There's so many different ways you can use it. You can use it as a 1-node cluster, a 3-node cluster. You can have 150 nodes. You know, it's a very in-depth product with all the different profiles. And that is kind of, you know, it's challenging for a lot of people that are just getting started to understand what's happening and how to move forward, or why they want to use something, or why they want to use a particular feature or function. So one thing that we want to build into this with the profiles is different kinds of cluster architectures. So having a 5-node cluster, well, you can have a 5-node cluster with cold, or you can have a 5-node cluster with frozen tier. What does that look like architecturally, and how does that perform? So by building out these profiles, we want to give people the ability to quickly stand up multiple different ways to see their environment, and then multiple different ways to see that performance on different types of hardware within their systems. Is kind of ultimately one of the big goals, and overarching on how we're going to do a lot of this here with this project. The other thing is we want to add in support for Podman as well. So if you're kind of in those environments where you're strictly on Red Hat, you can't bring in Docker, but you can do Podman. We're going to kind of show the comparable of like how to do this with Podman, and how to work within those RHEL systems and RHEL environments a little bit easier. There's a lot more that comes with those profile things, but that's kind of the generic of like architecturally saying what clusters are there, and then how do you build that out. We're going to kind of have like a tree diagram that kind of goes through all of the inner workings of the clusters and why you would architect it some way versus another.
I love it. I think this is going to be very valuable to a lot of people. They will see this used, get something very quickly up and running, air gap, not air gapped, on-prem always. Well, cloud could be as well, very doable in cloud. So yeah, I think this is great. Any other thoughts or comments before we move on?
I guess other one that's kind of in the architecture realm is a lot of people want to see how Elastic performs in some cases, and they want to understand how it works with their hardware. Deploying it is obviously the first step. But let's say you actually want to know throughput a little bit more. Elastic has a product called Rally that we use to do our macro benchmarking in our daily and nightly builds. Well, it's an open product that anybody can pull down and interact with. There's great documentation around that. We kind of want to also build in the instructions on how do you use Rally to interact with the system that you stood up with Docker Compose. That way, you don't have to just trust what we say. You can actually do it yourself, and you have the platform to consistently, repeatedly do this in some type of development environment, or in some type of environment where you got to show off how this works or how this functions. You can actually have the numbers to back it up and say, this is what it does.
I like it. All right.
Another thing we're trying. Oh, sorry.
Take it.
Another thing we're looking at doing is how to make the air-gapped environments, creating an example for accessing LLMs. We have a lot of great features in 8.14 that are based on AI and ML, and in an air-gapped environment, you may not have access to it. So I just saw a post come out last night about how to make Elasticsearch connect to a local LLM and using LM Studio. So that will probably be on our near-term agenda to figure out how to make those connections and get that example out there so that you can use things like attack discovery and the AI assistance within an air-gapped environment.
I mean, totally, that's a topic for another day, but the ease of use of building your own AI bot, I mean, we just threw out a really impressive beta just a couple weeks ago. It's just the beta. I mean, it's going to get to a point where the average person, you don't have to be a data scientist, you don't even have to be a developer, just the average person can build an AI bot with Elastic. So it'll be interesting to see where that goes.
Mm-hmm.
Yeah, and like you said, it's just the tip of the iceberg, man.